Now it's time to cover the largest section in ThinkUp Science, and that's the instruction section. Make sure to grab those teacher editions because you're going to find a lot of really great labs and activities to try with your students that will make science come alive and engage their critical thinking. Now make sure you watch these next few learning modules and we will cover everything that you're going to find in the instruction section, both the teacher edition and student edition. The concept exploration provides an opportunity for your students to investigate the unit concept. The student edition provides a hands-on investigation that students complete, and the teacher edition provides step-by-step directions, required materials, and possible results for the investigation. This gives you the opportunity to identify and address any misconceptions or confusion before the students work on their own. Every activity in the teacher edition provides a recommended grouping, the time the activity will take, and codes the activity to the TEKS, ELPS, Revised Bloom taxonomy, depth of knowledge, and the critical thinking traits used in the activity. You will also notice that the student edition provides opportunities for students to express and reflect on their learning and use the critical thinking in the unit. In Level 5, Unit 8, students work with a group to complete the concept exploration page in their student editions. In this activity, students are told that there are many ways to test force on objects. Using this information, they will collaborate with their group to plan an investigation to test force on one object from a group of objects provided by the teacher. Students generate the plan by walking through the tasks that are laid out on the page. At the end of this concept exploration, students are asked to examine results from the investigation and to formulate a written conclusion based on results. The teacher edition provides instruction and a list of materials needed to complete the concept exploration investigation. It is important to gather all materials needed prior to the investigation. Hands-on investigations allow students to link these experiences to scientific concepts. In this concept exploration, groups have an opportunity to ask a well-defined question, identify variables, form testable hypotheses, select appropriate equipment or technology, collect data through repeated trials, analyze and interpret information, organize information, and communicate conclusions. Prompts are provided in the teacher edition to lead students through a brainstorming activity to generate ideas for the investigation. Student groups cannot conduct their planned investigation until you approve the plan. Make sure all safety guidelines are followed throughout the plan. Students collect and record data using repeated trials. The teacher edition requests teachers monitor data collection and assist students with developing means to organize this data using technology tools. Groups analyze results from the investigation to formulate a conclusion based on the results. Prior to groups completing the concept exploration activity, the teacher edition provides insight into possible group results. It can alert you to expect some groups to generate plans that are less successful than others, and how to use this opportunity to discuss how to improve the validity of results. I encourage you to take time to emphasize that whether the plan was a success or failure, there are opportunities to learn and improve. In addition, I invite you to discuss with the class how results from an investigation may or may not support a hypothesis statement. This is okay because the hypothesis is only an educated guess, and they must report factual data. Also, highlight ways to support groups that are struggling to develop a unique plan to test force on an object. If many groups in the class are struggling, try to design one test as a class and complete the investigation as a whole class. Then allow the groups to design another option. Modeling these steps will prove beneficial to all students and prepare them for future activities that require these skills. The concept development section provides scaffolded instruction and explanation of the unit concept through the components examine the concept, apply the concept, and relate to the process skills. This scaffolded approach is designed to help ramp up the rigor over time to support students to master unit content. Students are also provided an opportunity to practice unit content as it relates to the process skills. These star-formatted items allow teachers an opportunity to determine if students can apply the content in a different situation. If students struggle With these types of items, teachers should provide more opportunities for students to participate in hands-on scientific investigations that expose students to situations that may be assessed through the process skills. As a former teacher, I know how vital vocabulary is in science. On assignments, benchmarks, and STAR, students will see questions using this academic vocabulary. Being able to read and write in science allows students to explain processes, cycles, and events. Since these skills are so important, we provide opportunities for students to practice and develop their academic vocabulary. The Teacher Edition lists all the essential vocabulary for instruction and mastery of the unit concept. It also provides an activity to reinforce these terms with your students before they do any individual work. In this unit, the activity is Show the Term. In this activity, teachers will distribute dry erase boards and markers to students. The teacher will read the definition for one of the listed vocabulary words to the unit. Just as a reminder, a glossary is found at the end of your teacher guide and student guide. Once the definition is read, each student will record the vocabulary word that matches the definition onto their whiteboard. When the teacher signals, students will raise their boards to reveal the written term. According to the Teacher Edition, this activity can be done in 15 minutes, and we recommend doing this individually with a student or a whole group. In the Teacher Edition, we also list a formative assessment that you can give to the students. In this formative assessment, we ask students to examine the unit vocabulary terms. The teacher asks a challenge statement for each term. For example, challenge statements may include name 3 terms that are types of a force. Name 2 terms that are related to experimental investigations. Name 2 terms that are tools. After the teacher asks several challenge statements, the teacher can invite a student who gave the last correct answer to give the next challenge statement. Lastly, the Teacher Edition also provides a list of literature that supports the unit concepts. These can be used to introduce, reinforce, or extend the unit concept. These titles can be used to build your classroom library. We have just done the work of gathering them into a list for you. An additional vocabulary practice is provided in the Student Edition as well. After concept development, you will find the Vocabulary Mastery page in the Student Edition. The activities go beyond writing down a definition. We want to challenge the students to apply their vocabulary knowledge to complete a task. In the Science Vocabulary Builder section, students have an activity they will complete. Here, students are asked to use the letters in the word force to create sentences and examples that describe the term force. The Concept Practice page in the Student Edition is an opportunity for students to practice what they have learned so far in a STAR format. In the Teacher Edition, we've equipped you with explanations for the correct and incorrect responses for each answer choice. These can be used in reviewing the items in the Student Edition. This gives you the opportunity to model thinking and the process of answering questions successfully and instill those practices in your students. Let's dive into Level 5, Unit 8, and look at the explanations for the correct and incorrect responses that are provided for Question 1 in the Teacher Edition. For this question, teachers are given explanations for the 4 answer choices so they can walk the students through each answer choice with thinking and reasoning to determine if the answer they chose was correct or incorrect. At the end of each explanation, it reveals if the answer choice is correct or incorrect based on the evidence presented. By walking students through this questioning process, this will help them catch the mistakes made in their thinking or help give them a voice to why their answer was correct. Finding the solution to a problem is a process, and we do not want to skip over this important process by just giving them the final answer. I believe that Ralph Waldo Emerson says it best. It's not about the destination, it's about the journey. The explanations provided in the teacher guide allows your students to see the journey they should have gone on to arrive at the correct destination. Now that you've modeled your thinking, students can apply and discuss what they've learned so far during instruction. There is a formative assessment following the concept practice section in the Teacher Edition. This is a great way to wrap up a lesson. It allows you to take a quick pulse of the student's understanding. The concept application section is an engaging way for students to apply what they have learned beyond the classroom setting. The concept application page in the Student Edition is an opportunity for students to apply what they've learned so far to a real-world scenario or situation. In the Teacher Edition, we've equipped you with step-by-step directions on how to complete the activity in the Student Edition. Let's take a closer look at the concept application activity for Level 5, Unit 8. In this activity, students collaborate in small groups to design a new roller coaster for an amusement park using the principle of force, gravity, motion, and acceleration. Groups develop a list of materials to create a model of the roller coaster, determine a variable to test in order to improve the roller coaster design over time, and ultimately create a model of the roller coaster to share with the class. The teacher allows groups to set up a class amusement park to showcase the roller coaster models. As the teacher invites each group to share their models, the teacher asks each group to discuss how the principles of force, gravity, motion, and acceleration are important in the roller coaster design. Now that students can apply science concepts to the real world, just like the previous selected response items, the concept application page provides 2 star-formatted items that integrate the process skills. As you can tell, students are using their critical thinking skills and knowledge of force to design and test roller coasters. Lastly, we want to give students a chance to reflect and think about their thinking. You will notice that this section in the Teacher Edition ends by asking a question. How has your perspective about force changed over time? Next to the question, you will see the icon Examine. Examine is one of the 9 critical thinking traits that are infused throughout ThinkUp science. When we ask students to examine, we are wanting them to think more deeply about information or a situation by using a variety of methods to explore and to analyze.